Okay, this is still chapter 1-1, and this is recording number 2. All right, so we just talked about what a variable is. We said that it's something that is a characteristic or an attribute. So if we're measuring the height of fifth graders, that is a variable. That kid himself, that fifth grader, he is not the variable. The variable is whatever the characteristic is that we're looking at: height, weight, grade point average, that sort of thing. Okay, and then some people get a little bit confused here about why is it called a random variable? Because, as I said, if you measure that kid, the height doesn't change, right? The height is whatever the height is. Well, but picking that particular kid is by chance. You pick that kid. That's the part that's random, I guess. I don't like the terminology either, to be honest with you. Okay, so let's get some more terminology here. A collection of data values forms a data set. Now, in the engineering world, and I think in the scientific world, but certainly in the engineering world, we don't we use a little bit of different language here. When I was working at the Norton Air Force Base, we would call it a data we talk about a data set, but then right here, the data value or a datum, that terminology was not commonly used. What we would say is we would say a data point. So you would call it a data point. That's what I think you'll see more often in the literature. Okay, what's a population? You've heard of the word population. A population is the set, it's a set of all of the subjects, whether it's a human being or whether it's something else, some sort of a scientific situation. Like uh, maybe the population might be the set of all hurricanes. Okay, that is your population that you're looking at. All of the hurricanes that have happened throughout history. So in any event, the population consists of all subjects that are being studied. So that's everybody. Okay. If you take data from the entire population, that's called a census, okay? And we do that every 10 years. By the Constitution says we have to do it every 10 years. Normally it's too hard. Normally it's too hard to do a census because you're talking about such a large group of whatever you're looking at. So what we normally do is we will take a sample. So a sample is a subset of the population. So that's what he's saying right here. A sample is a group of subjects that is selected from a population. And that seems reasonably easy to discuss, right? However, it's a lot harder than it looks to get these concepts straight. And we'll see as we go along here, I think, how it gets to be confusing. All right, so here's right here. This sentence right here is very important. If the subjects of a sample are properly selected, so in other words, you're taking a sample from the population. If you do it properly, most of the time, that refers to the subjects, they should possess the same or at least similar characteristics as the subjects in the population. Okay, so what does that mean? What that means is that let's take the population of the United States. The entire population of the United States or I'm sorry, let's use a little bit different. Let's take the population of Riverside Community College District. Now there's 3 campuses. There's tens of thousands of students, okay? So if you were looking at the population of Riverside Community College District, of all the students, it would be very difficult to do a census. However, it would not be so hard to do a sample. So you take a sample from the Riverside Community College District and you say, well, I want to draw some conclusions. I'm going to draw the conclusions from the sample. Okay. Now, if you do a good job, if you sample properly, you can draw inferences or draw conclusions that make sense. Okay. However, if you don't do a good job, the information obtained from a statistical sample is biased if the results from the sample are radically different from the results of a census, okay? So what you always want is an unbiased sample so you can draw your conclusions. So a sample is said to be biased if it does not represent the population from which it has been selected. Now, how do we do it? It's easy to say do it properly, but how do you do it? Well, that's section 1-3. We'll see that here in a few minutes. Okay, so now we want to talk about the two basic types of statistics. We talk about statistics being descriptive statistics, or we will talk about it being inferential statistics. Descriptive statistics, just like the name implies, is where you are describing something. So descriptive statistics like baseball, okay, if you ever watch baseball, you know they have an unbelievable amount of data. Every guy that comes up to bat, they can tell you, the announcers can tell you what his grade point average, or excuse me, what his batting average is, and how many times has he stolen first base, how many times has he stolen second base, and so forth. So those are, you're describing something, you're describing this player's history. So descriptive statistics consists of the collection, the organization, you summarize, and then you present the data. You're not drawing any conclusions. You're just saying, hey, this is the way it is. Okay, you describe the situation. So I'll let you read that. The second type of statistics is called inferential statistics. Now, let me digress a little bit. Do you understand the difference between to infer as compared to the word to imply? Okay, so to infer and to imply are two different concepts. When you imply something, the speaker is implying something. So if I said to you, you walked in the door and I said, hey, do you know what time it is? I'm implying that you're late just by the tone of voice. On the other hand, if you come in the door and you are all wet, okay, and you have an umbrella and you are shaking the umbrella out, and I say, oh, looks like you're all wet, looks like you have an umbrella, I infer that it is raining outside. Okay, so I'm drawing a conclusion. So that's what we're talking about here with inferential statistics. We are going to infer, we're going to draw conclusions from information that we have. Okay, so we take samples, we are going to perform estimations, we're going to do hypothesis tests, we're going to do all these things that help us make decisions. So for example, does this vaccine work? Can we draw the conclusion and we infer that the vaccine is effective and is safe based on the statistical analysis that we do? Okay, so as the author says, the statistician tries to make inferences from samples. So you have a sample, you have certain information from the sample, and you make an inference from the sample and you draw a conclusion about the population. Now, do you see, the reason we do this is because it's just too hard to look at the entire population. If we had infinite resources, I could draw a conclusion. I wouldn't have to draw these conclusions. I would have the information. So for example, let me just take the Riverside Community College District, the students again. There's like 60, 80,000 students. I can't possibly talk to all of them. But if I do a good job and do a sample, and I look at the sample and I say, oh, look at this. 80% of this sample have jobs. Therefore, I conclude, I infer that 80% of the population of the entire population, all of the students, also have jobs. Okay, I draw that conclusion, I draw that inference. Okay, so in order to do this, we have to use probability. That's the idea of a chance, or the likelihood of something happening. Okay, so we're going to talk about probability, I think, in chapter 4. It's a very, very big topic, to say the least. So we're going to use probability for that. Here he's talking about what's called hypothesis testing, and this is just a process for making a decision. So you say, well, I think that, I don't know, whatever, like using the community college district as an example, you might say, well, I think that students who take remedial math do a better job in statistics. So I draw samples. I take a bunch of kids that did do the remedial math, and I take a bunch of kids that did not do the remedial math, and I make that comparison. I draw my conclusion based on these two samples. So that's called a hypothesis testing. A hypothesis is your claim or your what you think is true. We'll see, we'll get a more precise definition in chapter 8 and chapter 9. Okay, so here's the example he's using. This is one that hopefully you nurses will really like. We're talking about a drug. We want to know whether the new drug will reduce the number of heart attacks in men age 70 years of age or older, I guess. Okay, so you pick two groups of men over 70, and one group gets the drug, the other group gets what's called a placebo. That's just like sugar pills or something that doesn't harm you, it doesn't help you, and then you make the comparison. Is there a statistically significant difference between the two groups? That's how you decide whether or not the drug is effective or not. So this is talking about heart attacks. It could be obviously the same concept is true for comparing when you eat your Wheaties breakfast cereal. Can you do more push-ups? Do you run faster? You could be looking at, you know, gasoline that has certain additives. Do you get better mileage? The concepts are exactly the same, and that's why I'm urging you, come up with examples that are of interest to you. Okay, so now here we're talking here about relationships. Okay, is there a correlation or a relationship between, in this particular case, he's talking about smoking and lung cancer. If you smoke, are you more likely to get lung cancer? So there's an example of an inference that you draw, a conclusion that you draw based on the data. Okay, so here's some examples here. Now listen, it doesn't do any good for me to just read this to you. You're all adults, so you can read this yourself. I'm going to help you read the hard stuff. So read this yourself. Here's examples. I'll do one. Is it descriptive or is it inferential? Okay, average price was X number of dollars. Well, that's descriptive. You're not drawing any conclusions, right? How about this? The Department of so-and-so predicts the population will be blah, blah, blah. That's a prediction. So that's not a description. That's a prediction. So that's considered inferential. Okay. This one here, if you take certain statins that allegedly lower heart attacks, okay, but on the other hand, you have a higher risk of developing diabetes. So that's hypothesis testing. That's going to be inferential. So that's right here. Okay, so you can easily do these yourself. I urge you to do it. It's not a waste of your time. Okay. All right. So far we haven't done any math part. All we're doing is just reading here, right? So this should be very straightforward for you. I think that's about it for chapter 1-1. So I'm going to end this video right now.